in the last video, we changed the WPA2 passphrase from something simple like hello there, which is in rocku.txt, and then we found that hashcat was taking quite a long time to go through the word list and to try to find the passphrase. The reason is that it has to go through one by one and compute and compare for a match. Is there a way that we can speed it up? Because we can imagine that rocku.txt is just one word list. What if the passphrase is not found there? We might need to use a much longer word list with many more words. Maybe even another thing is combinations of words. So what else can we do? It turns out that when we were just running hashcat, it was using the CPU. Most operations on computers will be running on CPUs unless we arrange otherwise. So for example, there are GPUs, graphics processor units, that are available in many machines. Usually they are reserved for the computations for the display, but for certain kinds of operations, like these kinds of computationally intensive operations, it makes sense to try to run them on the GPU rather than the CPU. CPU is more general purpose. Can we run hashcat on a GPU? Well, it turns out it's not so simple to just run any piece of software on a GPU, because these GPUs have specialized drivers and you need to do something a bit tricky. You need to do certain things in order to get software to run on GPUs. Generally then, if you want to do certain computationally intensive operations on GPUs, you would find that the best way is to go for software that is intentionally written to make use of the GPUs. Hashcat is one such example. Hashcat works with a variety of GPUs and it offloads computation of hashes, which would be things like passwords and so on, onto GPUs rather than to use the CPUs, which would be slower. So hashcat can schedule these computations and it can also detect the various GPUs. So it is designed to work with GPUs and multiple GPUs, not just one. It is open source, runs on Linux, Windows, Mac OS. You can compile it to run on a variety of different operating systems. Now, it may not be so easy to get it running properly though, because there's various issues about drivers and so on. That's another matter. We will be showing some demos and you will see some of the challenges, some of the issues that are faced as we go through the demos. It supports a wide range of computations, so it is not just meant for WPA or WPA2, unlike hashcat, which is more specific for Wi-Fi related cracking. Hashcat is designed to support various kinds of brute forcing, especially things like password recovery, passphrase recovery and so on, where the typical process is that you're going through a large word list and you want to brute force, you want to check. You typically then will be computing hashes again and again and again and comparing these hashes with some value that you might have obtained. In the case of our WPA2 cracking, this was in the four-way handshake file. So this process is quite similar to password recovery and various other computations for a wide range of scenarios. Another thing that hashcat supports is rules. So there might be certain rules where you don't just use the word in the word list as the only possible passwords or passphrase or whatever it is, but maybe certain rules like you can combine, so you have combinations of these words and you also try combinations of these words. That makes it more powerful than if it were just to simply use straight direct brute forcing. How do we install hashcat? We can find the hashcat packages just by Googling, and there's different versions of them. So we will see when we go to the demo that sometimes some package might come with pre-built executables. For example, we will find that the latest one does not come with the pre-built binaries for Windows, whereas the next to latest one does, and so we would use that one just for convenience. There's also samples that come with these packages. We can also build from source, and so if we have time, we might do that just to show, like to build on Mac OS. And generally, we're going to need to update various drivers and related bits of software. We will show that in the demos as well. because typically your GPU drivers might not be up to date, and then you might have problems getting hashcat to work with those older drivers. Generally, the latest versions of hashcat would like to work with the latest drivers to fully utilize the GPUs and the capabilities of these GPUs. A popular practice for using hashcat is to run it in the cloud. For example, EC2 machines on Amazon Web Services or AWS. These are virtual machines that you can get on Amazon, and it's very convenient because if you just need to do something, you could just for an hour, you can start a machine for an hour and then you can stop it, and you just pay for what you use. It's also convenient because, for example, later we will see in the demos, when I am installing on my physical Windows machine, I might find that I might not have enough RAM on that machine and things like that because it's an older machine, and then hashcat might not work with that. Whereas with EC2, you can get an instance that you know has enough resources and is able to run hashcat properly. So we will show a couple of demos on Windows, because I think a lot of people would want to use Windows if they're not using the convenience of EC2 on AWS. So we'll show how to find the GPU that's installed on your Windows machine and how to install and run hashcat. In this case, as I mentioned, my laptop didn't have enough RAM, and I thought, well, okay, I can go get more RAM, or I can just show you how to do it on EC2 on Amazon Web Services. I will also show a demo on that, and if there's time, also on Mac OS, how to install hashcat.